gases. The bullet then passes through the baffle chambers, while much of the hot gases are left behind. The gas that does pass through expands in the spaces between the baffles. Finally, the bullet exits into the outside air after passing through a hole in a rubber endwipe. The hole in this rubber endwipe is only slightly larger than the bullet. This creates a partial gas seal. In order for you to appreciate the performance of the improvised suppressors we will demonstrate, we need to know something about decibels and frequency. Observe this field test. Both weapons are firing the same .22 long rifle cartridge. The first weapon has been suppressed by a major Class III licensed manufacturer and is clearly much quieter than the unsuppressed weapon. However, to the observer present, the difference in noise level is far more dramatic than the audio track of this videotape can demonstrate. The decibel meter shown here measures the intensity of sound. What is needed is a familiar frame of reference of the decibel level of common sounds. This will allow you to compare the noise level of these familiar sounds with that of our improvised suppressors. This TV set, at normal volume, registers about 48 decibels. The volume is then turned up all the way and the instrument recalibrated. At full volume, the TV registers 56 decibels. Dropping the book directly in front of the sensor, 69 decibels. The balloon pop in front of the sensor registers 74 decibels, but if we move the balloon back just 3 feet, the decibels drop off dramatically. We will be examining decibel drop-off over a distance shortly. Move back just 3 feet, we get a register of 66 decibels. The pellet gun registers 64 decibels. This .22 pistol registered 110 decibels. We will be using the following graph as a baseline of comparison for the noise level of our improvised suppressors. Recall how sharply the decibel level dropped at a distance. Our common sense and experience tells us that things happening further away don't sound as loud. But let's examine this relationship between sound level and distance more closely. The green line represents the drop-off of bullet velocity, the pink line the constant speed of sound. The blue line represents decibel drop-off at a distance. Note that at the muzzle, the weapon registered 180 decibels, but after traveling 550 yards, its sound level has dropped to about 20 decibels. Recall our field experiment. Disposable suppressors are just that. Recall our 2-liter pop bottle suppressor shown earlier. The ballistic nylon catches the .22 caliber bullet. This unit registered 77 decibels, a drop of over 30 decibels using subsonic ammo. This pistol fires the .22 short cartridge at right. The .22 long rifle at left is shown for comparison. This tennis ball provided the disposable suppressor for this diminutive cartridge. It registered 54 decibels, about the same as a loud television set. The 2-liter bottle shown earlier achieved its silencing effect by providing a single large expansion chamber for the muzzle gases. The tennis ball also provides a superior gas seal, as the first shot creates the exit hole. Though good for only one shot, the power steering bottle dropped the sound 16 decibels. We now examine the construction of improvised suppressors. Our first unit is designed for the .22 caliber pistol. The body of the suppressor is made from ordinary 1-inch steel electrical conduit. It is cut using a pipe cutter. This achieves a flush, smooth end. Standard 1-inch grommets will provide our baffles. These grommets fit nicely inside the 1-inch steel conduit and are therefore self-aligning. Sometimes the grommets will require a little bit of grinding to achieve this ideal fit. The 1-inch steel conduit at top is 1-inch inside diameter. The aluminum tubing below is 1-inch outside diameter. This means that the aluminum tubing slips inside the 1-inch conduit. The aluminum tubing will provide spacers for our grommets. The standard 1-inch grommets thus fit flush and even with the 1-inch aluminum spacers. Brass tubing is also available in 1-inch outside diameter. In this first design, a piece of brass tubing will be used as a barrel extension. This tubing has the same outside diameter as the holes in the grommets. Cuts are made in the barrel extension to allow the gas to escape into the dampening materials. A high-quality epoxy is used to attach the grommets to each end of the barrel extension. A piece of steel screening is cut the length of the space between the two grommets. The steel screening is then wrapped around the barrel extension. Rubber bands are used to temporarily hold the screening in place. The screen is then secured with metal twist ties. Using a technique of the Class 3 manufacturing pros, white lithium grease is added to the screening material. This will help cool the hot expanding gases. A small piece of screen is rolled up and insert it into the aluminum spacers as well. It